Alright, good day and welcome. Today I'll be going over my project for FSE-100 Deliverable 4, and we'll be discussing the electronic side of my climate control drone slash irrigation bot. It kind of does both, big tank of water, things like that. So as you can see from my original 3D drawing, I have a soil moisture sensor, which was originally meant to have an IR emitter with it. I have the 3 LEDs, a temperature sensor, and a servo motor that will be controlled. And when the soil moisture sensor senses the need for water, it is supposed to turn at 20 degrees. And this is why, let water out, and then when it's finished, it'll go back to 0. So this is kind of what we have for that design. With this, we have a temperature sensor here, which will activate a blue LED if it's too cold or equal to or below 21 degrees Celsius, a green LED if it's between 21 and 32 degrees Celsius, and a red LED if it's 32 degrees Celsius or above. And in addition to that, the original intent was for the drone to send use an IR emitter to send a signal to the thermostat to increase, decrease, or hold temperature respectively. So with that said, we can go ahead and kind of show how it works. With the temperature being at or below 21 degrees, it turns blue, indicating that it's too cold. In the serial monitor here, we're asking the thermostat to increase temperature, and that works all the way through this range here. But once we get into perfect temperature, it activates the green light, tells us that the temperature is an acceptable range. But as soon as we hit that over 32 mark, the red light will come on, indicating that it's way too hot in here, and sending the signal to decrease the temperature. As for the soil moisture sensor, we're just, as soon as the soil goes dry, the soil moisture sensor originally was intended once again to use an IR emitter to send a signal wirelessly to the drone. As it is a drone, it is hard to stick this in the ground for each plant. However, with that unavailable to me here on TinkerCAD, I just plug this straight into the Arduino board. And so when the soil moisture sensor gets too low, as you can see, our servo motor has now turned 20 degrees already. And so as it fills up, once it hits the predetermined threshold, our servo motor will now close that stopper, halting any more water from being distributed. A quick overview of our code here. In this first section, of course, I go through and I identify all of my inputs, outputs, connections, things like that, assign them where they need to be. In the void setup, I assign what they need to be. And then in the loop function here, I convert my temperature reading from voltage to Celsius. And the way I've done that is through a map function by taking the voltage that I have. It took a little bit of math to find the perfect range, but then this is the range that I was left with, and this is the range that I have changed it to, which match up with what TinkerCAD has in here. The moisture, straight analog reading, so that when my temperature sensor reads that it's too cold, it turns off 2 of the LEDs, only leaving on the blue LED, and then prints that the thermostat needs to increase temperature. Likewise, if it gets too hot, turns off 2 LEDs, only leaving on the red LED, and then perfect will do the same but with the green LED. As for the moisture sensor, once it is equal to or below 375, that tells me that the stopper needs to activate, rotate, let some of that water out, but as the water is pouring, this is this delay here, this loop is running every 1 second, and so once it has enough water, it will close the stopper. And this is just after everything needs to print the degrees Celsius, so we know kind of where we're at with the thermostat. But that is my current electronics, and I hope you enjoyed. Thank you.